Hello my dear students. Now we are going to derive an expression for magnitude of the magnetic field at a point along the axis of a circular conductor carrying current. Okay, this is one very important derivation as far as board examinations are concerned. Also, this is a very important concept for all the entrance examinations. We will do the derivation. So here we have to use Biot-Savart's law. Okay, or in the question they may also ask you like this, using Biot-Savart's law. They may also ask you this. Okay, using Biot-Savart's law. Okay, so we know what is Biot-Savart's law. So according to Biot-Savart's law, magnetic field produced due to a current carrying conductor is equal to, we know this equation, mu naught by 4 pi into I dl sin theta divided by r square. So using this law, we have to derive the magnetic field due to circular conductor carrying current. We will consider a circular coil carrying some current. Say the current flowing through the coil, let it be I. I is the current flowing through the coil. Okay. Now this is the center of the circular coil carrying current. So this is the axis of the circular coil. Okay, this is the axis of the circular coil carrying current. Okay, this is the axis. Now let us suppose that I want to calculate magnetic field at some point P. This is the point P where I want to calculate magnetic field. So if I have to use Biot-Savart law, I should consider a current element. So here I will consider a current element. Okay, say this is one current element I have considered. Length of that current element, let it be dl. I will consider one more current element. Let us name it. This current element is AB and this current element is A prime, B prime. Length of this current element is also dl. Now the radius of the circular coil, okay, circular conductor I have considered, let it be capital letter R. Okay, and the distance of the point from the center of the circular carrying conductor, let it be x. This distance is x. Distance between the current element and the point P, let it be small letter r. Okay, this distance, let it be small letter r. Now what is the direction of magnetic field here? Magnetic field is in this direction, because that small magnetic field produced should be perpendicular to this r and the current element, because dl equal to db equal dl cross r. It's a cross product. Okay, angle between this r and db should be 90 degree. Okay. Now what we will do, this current element dl also produce some magnetic field. That magnetic field I call it as db prime. Okay, db prime, but we know that both are same. Magnitude of both is same, because this distance is r, this distance is r, and the length of both the current elements is dl itself, current is I itself. Maybe these two magnetic fields have different direction, but their magnitude is same. Now what we will do, we will resolve this magnetic field. Okay, db. Yeah. Now this dB, now this angle, let it be phi here, this angle is phi. If this angle is phi, okay, and this angle is 90, what happens? This angle will be equal to phi. This angle will be equal to phi. If this angle is phi, see, angle between r and dB should be 90 degree. So therefore this angle is 90 minus phi, correct na? 90 minus phi. Because here this angle is 90 degree. So this is phi, this is 90 minus phi, and we know that this angle is 90 degree. Therefore, if this is 90 minus phi, this should be equal to phi. Hope you understood this. So therefore, I have written, if this angle is phi, this angle is also will be equal to phi. Then what is the vertical component of dB? Vertical component of dB is equal to dB cos phi. What is this component? dB cos phi. What is this component then? This is dB sin phi. dB sin phi. Okay. Now we'll resolve this dB prime. Okay, if you resolve that dB prime, okay, say this is dB prime, so we are going to resolve dB prime. If this angle is this angle, yeah, this angle will also be equal to phi. Okay, what is the vertical component of dB prime? Vertical component of dB prime is dB cos phi. Okay, because magnitude of dB prime is same, dB itself. Okay, dB cos phi. What is this component of dB prime in this direction? What is this? dB sin phi. Okay, so why here I have written dB? Because magnitude of dB is equal to magnitude of dB prime. Okay, magnitude of dB prime. Now according to Biot-Savart's law, what does it say? Biot-Savart's law, dB is equal to mu naught by 4 pi into IDL sin theta by r square. This is the first step of the derivation and is very crucial. Okay, what is theta there? Theta is the angle between current element and the line joining the current element and the point. This is very important. Okay, so theta is the angle between, okay, current element, this current element, okay, and the line joining the current element and the point. See, I'll give you an understanding. If there is a circular coil carrying current, okay, and there is a point here, this is the point, okay, this is the point. What is the angle between this current element and this line? That angle will be 90 degree. Okay, hope you can understand. Say suppose you have a circular carrying conductor like this, and this is the axis of the axis. Okay, then here there is this is the current element. Okay, this is the current element. Okay, and this is that R, this line is there, na? Okay, say here I have considered a point on the axis like this. I have considered a point on the axis. Okay, so what is the angle between this R and the current element? You see it is 90 degree. Okay, because you take out that current element and you keep it here. Okay, now what is the angle? 90 degree. See, now what is the angle? Current element, I have taken that current element out, small current element, and the R. What is the angle between them? 90 degree. Okay, in the diagram it is very difficult to specify it. Okay, so therefore this theta is equal to 90 degree. Okay, therefore dB is equal to mu naught by 4 pi into IDL by r square. Why? Since theta is equal to 90 degree. Okay, so this is the current magnetic field due to that current element. Okay, now if you look at this diagram, okay, this dB cos phi, this dB cos phi and this dB cos phi, they are equal and opposite and they get cancelled. Okay, and this dB sin phi and dB sin phi, they add up, okay, to give the resultant magnetic field. But here there are so many current elements. Okay, to calculate total magnetic field, therefore what I should do? Total magnetic field should be equal to summation of all those dB sin phi's. Okay, summation of dB sin phi. Okay, we'll continue the derivation in the next page. B is equal to summation of dB sin alpha, summation of dB sin alpha. But what is dB? dB is equal to mu naught by 4 pi into IDL by r square. Okay, summation of dB means what? Mu naught by 4 pi into IDL by r square into, what is sin phi? From the diagram, what is sin phi? Sin theta is equal to opposite by hypotenuse. Okay, what is sin phi? Into R by R. Now what happens here? Total magnetic field B is equal to okay, mu naught by 4 pi into I into R, okay, divided by R cube. R square into R cube into summation of dl. Okay, what is summation of dl? If you look at the diagram, dl is the small portion in this circular current carrying wire. So if you add all those dls, okay, you are going to get circumference of this, total length of this conductor, that is 2 pi r. So magnetic field is equal to mu naught by 4 pi into I into R into what is summation of dl? Summation of dl is 2 pi r. Here, what is small letter r in the diagram? What is small letter r? What is this? Okay, what is this? Since it is the hypotenuse, okay, I can write this r square, okay, r square is equal to r square plus x square. R square plus x square, or this r is equal to square root of r square plus x square. So therefore, in the place of r, I will substitute square root of r square plus x square. So in the place of r cube, I will write square root means to the power half, correct na? Square root of r square plus x square cube, correct na? Hope you can understand this. I have to write r cube, but what is r? R is equal to square root of r square plus x square, okay, into 2 pi r. Now here what happens? So this will be 3 by 2. So therefore the total magnetic field B is equal to mu naught by 4 pi into 2 pi I r square, correct na? 2 pi into I into r square divided by r square plus x square to the power 3 by 2. So this is the equation for magnetic field due to a circular conductor carrying current, okay, on its axis, okay, because we have considered the point on the axis of the circular coil. Now if there are n turns in the coil, then what will happen? This equation will be equal to B is equal to mu naught by 4 pi into 2 pi n I r square. So n is extra, 2 pi n I r square divided by r square plus x square to the power 3 by 2. So here the derivation is completely over. Now we will write a special case, okay, note. So for note, what is the note? If the point P is at the center of the coil, at the center, okay, means what? If you consider this point P here at the center, then what will happen? X will be equal to 0, correct na? Yes, x will be equal to 0. So what happens? When x is 0, r square to the power 3 by 2, r square, this 2 gets cancelled, r cube, and in the numerator there is r square, that r square gets cancelled. So you are left with the capital letter R. So what we can write? B will be equal to mu naught by 4 pi. B will be equal to mu naught by 4 pi into 2 pi ni divided by r. Okay, why? Because this if point P is at the center, okay, what happens? X is equal to 0. If x is equal to 0, r square to the power 3 by 2 will be r cube. Numerator there is r square, that r square gets cancelled and 1 r will be remaining. So you can simplify it further, okay, you can remember this or you can simplify it further. So 2 pi goes 2 times, okay, what happens? Our magnetic field is equal to mu naught Ni mu naught Ni by 2r. Okay, if you consider the point on the axis of the circular coil, then the magnetic field will be mu naught Ni by 2r. So this will be useful. Hope you understood the derivation. Thank you very much.